GrandpaGeek.
Kyler, I understand you have a question for me today.
Yes, I do. So, the other day I was watching Ant-Man and the Wasp, and in the movie, they travel to the quantum realm. So I was wondering about quantum mechanics and how that works.
Okay, well, that's a great question. Actually, a pretty challenging question, because physicists today are still debating a lot about quantum mechanics.
Really?
First, let's look at the words and understand that. So, quantum is a word that means a small quantity. In fact, the definition, I wrote it down here, is a discrete quantity or amount of energy proportional to the frequency of the radiation it represents. So what that really means is it's a really tiny amount of energy.
That makes sense.
Tiny amount, right? So mechanics in physics is the study of bodies in motion, right? So how you move things around, like levers and pulleys and things. Those are all part of mechanics because you're moving bodies around. So quantum mechanics is about moving really tiny things around.
Oh.
And it's really about subatomic particles, right? So you know what an atom is?
Yeah.
Well, an atom is made up of particles, right? You know what's in an atom? Some of the particles?
Electrons.
Right.
Neutrons.
Protons, right?
Protons.
So it's got a nucleus, right?
Yeah.
And the nucleus always has protons and neutrons in matching quantity, right?
Yeah.
And then it's got what's called an electron cloud around the nucleus. And so how those subatomic particles behave is the study of quantum mechanics. Now this is where it gets really interesting, because going back for several hundred years, first starting with Isaac Newton, he described everything in terms of particles, right? So you could think of light as being a bunch of photon particles. But what's tricky is, as science progressed, they discovered things like diffraction. And you can't explain diffraction from particle behaviors. In fact, you can only explain it in terms of waves. And we know that, in fact, light has frequency, because that's where color comes from, the various frequencies of light.
Yeah.
And so there's this thing called the particle-wave duality of quantum mechanics. And what it really means, and I have a quote here from Isaac Newton, which is great. So Newton said, I'm just going to paraphrase it. He said, sometimes you need to use particle equations, sometimes you need to use wave equations, sometimes you can use either one, and they describe the behavior of the particles, subatomic particles. So it's really puzzling, because for certain things you can describe it best with particle equations, and for other things you describe it best with wave equations. So we've talked about what is a quantum, what is mechanics. We've talked about subatomic particles, and you know what those are.
Yeah.
We've talked about this wave-particle duality, is what they call it in physics. And then there's a couple other principles in quantum mechanics that are really interesting. One's called the uncertainty principle. So what that means is that because we have these electrons that are moving around the nucleus, right?
Yeah.
But they're not moving in a perfect orbit. They're moving in a way that they're moving up and down, they're oscillating. And the problem is, we can either measure where they are or what direction they're going in. But we can't actually measure simultaneously their position and their direction. And so that's part of what's called the uncertainty principle. And it's easier to represent the probability of where they are in terms of a wave. They're somewhere in this wave, but not necessarily be able to describe exactly where they are or what direction they're headed in. So that's one of the main, really deep concepts of quantum mechanics.
Okay.
There's one other concept that I want to bring up too, and it's called the correspondence principle. Now this one is interesting, because there are a lot of physicists who say the way that you can describe the movement of large bodies, mechanics, right?
Yeah.
Or think of it this way, the objects like are in our solar system, the way that planets and moons behave, right?
Yeah.
the way that those objects behave, the same rules should apply to quantum mechanics, to subatomic particles.
Yeah, 'cause
So
the planets,
there's, yeah,
the planets don't orbit exactly in a circle.
right. They have elliptical orbits,
Yeah.
and so the point of this concept of correspondence is there ought to be one set of rules that explains how everything behaves. And so it should work with the really big objects like planets, and it should work with the really tiny objects like subatomic particles.
Yeah.
Except it's not really proved, nobody's been able to prove that that actually works yet. But it's an important concept and a source of a lot of debate. So what's the significance of, excuse me, what's the significance of quantum mechanics? Well, the most important thing is that quantum mechanics is used to try to describe the behavior of light and matter, because you have these subatomic particles that are going to behave in certain ways, and that's going to cause certain things to happen in the world around us. So understanding quantum mechanics is a way for scientists to predict how nature is going to behave. That maybe by the time you're my age, science will have advanced far enough to really explain the apparent contradictions in quantum mechanics. But it's a very deep and much debated part of the world of physics.
That's cool.
That makes sense?
Yeah, it does.
Okay. I hope if you have any thoughts, any suggestions, better explanations, please leave comments below.
More questions?
Yeah, we want everybody to engage in these conversations. I'm doing my best to explain the questions, but it'll be more fun if we get comments and people engaging and helping to elaborate on these things and maybe even clarify things better than I could. All right? Thanks for joining us. Come back. See us again. I think it'll be Kenzie's turn next time to ask me a question. All right?